Welcome to the SliceNet webinar, which is the fourth webinar in a series of webinars that the project is organizing. This one is about system architecture. And the purpose is to present the technical achievements and innovation focusing on 5G system architecture definition, evolution, and vertical use cases analysis. The webinar will present the architectural design and the functional decomposition, defining the end-to-end slicing-friendly architecture, identifying the multi-domain slicing challenges and principles. It will summarize the main SliceNet achievements for vertical-centric, multi-layer and multi-domain slicing control and management, business roles alignment with multi-domain slicing, and will be highlighting the information model, ruling, service, and slice orchestration logic. Our presenter today is Marius Iordache from Orange Romania. Marius has 15 years experience in telecoms. He has experience in planning, designing, and architecting complex fixed and mobile networks. He is the 5G Technical Program Manager at Orange Romania, involved in adapting and aligning the 5G commercial developments to the industry and standardization releases. He is involved in 5G services definition and evolution from 4G systems to 5G non-standalone and further then to standalone. And he's responsible for the first 5G commercial launch in the Orange Group. The area of interest is covering also the telco virtualization introduction, the infrastructure as a service concept, and he's involved in the virtualization program for network functions. He's further also involved in the service-based architecture components deployment, and he's involved in several 5G PVP Horizon 2020 research projects as a contributor and project manager, in particular involved in verticals requirements and 5G business cases system and architecture definition. So Marius, I hand over to you, and please go ahead.
Hello, everyone. Hello, Tassos. Thank you for your introduction. Please confirm me that you can hear me well.
Yes, we can hear you well. You are no presenter, yeah?
Yes. I will share my screen. So now I'm sharing my screen. Please, before starting, confirm me that everything is fine, so we can proceed.
Yeah, everything is fine on your side, Marius. I would like also to remind all attendees, if you have questions, please provide them via the chat function of the WebEx, and we'll take them at the end. Please do not interrupt the speaker while he's presenting. Thank you.
Thank you, Tassos. So we'll start today our SliceNet webinar related to SliceNet system architecture, in fact SliceNet system definition. That will mainly be focused on, let's say, activities of dissemination of the SliceNet technical achievements and innovation. For the system architecture, mainly compared to the 5G system architecture and the use cases, that will further follow, let's say, this webinar agenda. I mean, we will have an introduction. We will discuss about requirements and challenges during this proposed system architecture. We will introduce the vertical requirements and identification of the vertical requirements as a vertical in the loop use cases, and we will describe the challenges coming from the verticals. We will highlight the architecture design and the functional decompositions in line with the end-to-end slicing reference architecture and what we have today in the standards for the 5G system service-based architectures, and of course at the end of the webinar, based on the questions that you will put on the chat, we will try to answer. So the approach in the project as it was already somehow mentioned, it is to design, to prototype and demonstrate innovative, quality of experience-driven 5G network slicing, and the appropriate framework, with a main focus for the cognition part in cognitive network management, including components from the control plane, end-to-end slicing operation, different slice-based services, in different scenarios, single domain and of course multi-domain operator domains for the 5G network. So as we have started years ago, 2.5 years ago with the project, with this approach, compared with reference architectures at that period. As a brief introduction, the main purpose of the project was to introduce this end-to-end cognitive network slicing and related slice management framework in a virtualized domain for the 5G network. So the main project objectives, as are highlighted on the slides, are to achieve and to demonstrate the innovative framework, including cognition, including one-stop API related to the vertical, focusing on the slice concept, slice management framework for different business roles and responsibilities, to extend, to enable the concept from the end-to-end perspective related to the full configuration accounting, performance, and security management across different, let's say, operators or different domain, to introduce in the for the 5G system architecture and mainly for the telco, this cognition part related to the quality of experience management, slices, and also the relation with the business vertical, and to provide a framework from the orchestration level, from the management control, and of course for the services. The concept, it's well related to the use cases, different use cases that should be served by this proposed infrastructure in relation with a concept like plug and play, that like one-stop API, a concept that in fact are capable to expose different network and service capabilities to the use cases and to be consumed by use cases. Of course, this approach is extended to different component and network domain, including the mobile network, the concept from the radio access network, mobile edge computing or edge computing, core network with the main elements, 4G and further 5G related, and interacting also with multi-domain capabilities. So inside this work package, we have defined goals, and the goals are highlighted like or one of the goals was to define the end-to-end slicing friendly reference architecture, what means slicing, how we are related with the 3GPP standardization phases, and of course to provide a clean slate approach for the SliceNet. Another goal was the identification of a multi-domain slice challenging, how this multi-domain can interact, how this multi-domain can affect the network deployment, development, and slicing perspective, and of course how these use cases can be deployed in such a multi-domain scenario. It was one of the main requirements and main ambition to bring in the loop the vertical requirements, to identify different use case needs, and of course to translate those needs into the system requirements for the infrastructure. Another goal, it is related to the proposed architecture and design from the functional perspective, including not only the basic principle for slicing control plane over different 4G or 5G infrastructure, but also to introduce in this architectural concept the main, let's say, management and orchestration rules and roles for our domain scenario. Of course, based on those goals, they have been identified several challenges, as the main challenges can be seen and will be presented here, related to different, let's say, slicing concept and definition, using different ongoing research activities and efforts, even in the standardization process, but also in the 5G PPP project, using different open source projects and, of course, standardization process and activities. And, of course, to try to tackle all this slicing concept within a consensus and to have a common vision based on all the activities that have been performed until that moment. Also, another challenge, in fact, was the effort to align different 3GPP specification development related to the slicing concept, related to the 5G system architecture, related to the, for example, life cycle management in the 5G system, with our proposed network architecture, including also different concepts that at that moment and were not well defined in different standardization bodies, related to the quality of experience metrics and how this quality of experience metric are related to the 5G use cases and also, or to different use cases, and also how we can influence through the quality of experience metrics through different, let's say, innovative activities, the quality of the services for the service that we provide for such of infrastructure. Another challenge was to introduce, at least from the telecom perspective, an cognition part and artificial intelligence techniques and machine learning techniques adopted in the network that will interact with different control and management plane infrastructure for different subjects. And of course, another challenge that we had to cope was the lack of vertical involvement as we were used to do in the service design and life cycle management. So based on this, using these goals and acting with these main challenges, we concentrate the effort to the different SliceNet use cases as covering different, let's say, vertical user requirements, including 5G smart grid self-healing use case, 5G smart city use case, and 5G e-health use case, connected ambulance, in fact. Due to the fact that we have introduced in the loop the verticals requirements, in fact, for the definition of the system requirements for each verticals, we used all the, let's say, KPIs related to the vertical based on the vertical involvement in order to collect and identify different development process, of course, in order to be capable to define and further to deploy 5G services related to the technical requirements of the 5G services. So several of the requirements are highlighted here, related to the availability, coverage, connection density, traffic volume, concept for multi-domain slicing, and of course security concepts. to be highlighted and further in different work package to be implemented and treated, concept related to the latency or the data for each use case. So this use case requirement identification for specific use case scenario provide us the capability to involve the verticals and also to bring at the end the 5G services for each of them. We have succeeded during this work package to have a clear picture, a clear view for each of these use cases, starting with smart grid self-healing. In fact, a 5G communication for this self-healing automation in energy distribution with the introduction of network slicing that will enable, let's say, operators to have a good performance in terms of significant reduction in the outage duration. The other use case, the second use case related to the paramedic use case supported by slicing, e-health use case that is served by a 5G communication with priority for quality of the services. Of course, that would provide to the end user, that in fact is a doctor interacting with a patient, the good quality of services and quality of experience for the health scenario. And the third use case, it's a 5G communication for smart city, use case managed by Orange Romania together with a consortium, and of course having in mind to enable an IoT network and different application to use different information from the network and the use case perspective to build an intelligent smart city use case for smart, mainly for smart lighting. And what is relevant for each of these use case has been applied and have been introduced different scenario related to the cognitive part in order to ensure the quality of experience and of course the quality of service for each use cases in relation with different component of the infrastructure. So because we try to be correlated with the 5G system overview and with the standardization process, we have to do this alignment at that moment related to 5G system architectures, 5G system, let's say, support for different KPIs in terms of latency, throughput, and density, and so on, that have been already identified in our cases, and to adapt the development and the deployment to the 5G system, mainly, let's say, like that, requirements, including the virtualization concept, the service-based architecture. That means, in fact, modular services, flexibility, adaptability, different deployment cycles for different, let's say, management and control activities, and of course to define from the concept perspective, and then based on the available technologies used in the project, to have the first slicing model that further to be put in place when demonstrating the three use cases. So from this use case perspective, one of the most important concept was network slicing definition as a framework that will provide us, in fact, the logical network created with specific isolation, with specific resources, with optimized topology that will serve the purpose of our case. For example, a smart city use case characterized by massive machine type communication in an IoT environment, or smart grid use case mainly focused on the ultra reliable and low latency communication. Also, this framework that is designed to provision our flexible and cost-efficient network, has introduced, as already mentioned, the vertical in the loop. Based on that perspective, there have been introduced different technical use case requirements related to the slicing concept and further, including to create a slice, to configure a slice, to ensure different capabilities related to FCAPS management to do the slice, to have a cognition-based slice management that will, in fact, applying this cognition part to the slice will give the possibility to the system to have a self-healing, self-optimized network, to introduce the concept of multi-domain slicing, including perspective related to the one-stop API or plug and play, and also to have in mind the concept of slice design and life cycle management, as also all these concepts are correlated with the standard. Of course, there have been analyzed different network slicing definition and possibilities based on different technology availability. So for the moment, almost all the network components that exist even in commercial or in the open tool source environment are mainly based on 4G. Based on that, it have been identified several types of slicing creation, starting with a core network, but extending these slicing capabilities to the radio network part. And all this scenario illustrated here started from different PLMN implementation that requires core network selection support, and of course support from the device part, or to create slicing based on the APN, to configure different APN that will be capable through the network composition to distribute and isolate different sessions, or to use let's say a dedicated core network, a decore implementation based on standardization process that it requires involvement from the core network part, including HSS support, and of course requiring also core network and radio network support, so complicated from the network perspective and from the component used in the project, or going further, analyzing the enhanced dedicated core, requiring support for the proper core network selection from radio network part, user equipment, and run radio access network support. And of course, the 5G slicing concept, the real 5G slicing concept, described based on 3GPP 23.501, that in fact it's described based on the service-based architecture and slice composition of the using slice template and slice and service descriptor, having fully support from the radio part, from the AMF part, UDM, and of course with deployed components in the control plane as NSSF. So this principle being analyzed, and from the SliceNet perspective, it has been identified the concept of using slicing based on the PLMN, different configuration PLMN at the core network part and the radio network part, using S1 Flex capability interface from the radio part that will give us and gave us in fact the possibility to direct proper traffic from the proper use case based on the PLMN analysis to the proper core. Based on all these existing standardized concept capabilities, 5G system requirements, vertical in the loop involvement, KPIs, and so on, it has been defined the SliceNet architecture based on 4G, 5G network data plane and control plane, and of course highlighting as a service-based architecture different component for different activities, including the control plane for radio access network part, for mobile edge computing, for different backhaul controller and data path controller, and for the multi-domain one controllers. For each of these controllers have been defined different adapters that in fact will allow different function to be run, including the PMP controls or network function configuration or control plane service registry. Another important topic was related to and was defined in this architecture related to the monitoring part, including resource monitoring, traffic monitoring, and of course topology monitoring. The definition and implementation of the inventories and different catalogs, and innovative concept of aggregating the data through a data lake implementation, and all this data to be consumed by the SliceNet cognition subplane in the cognition part, using different machine learning, AI algorithms and techniques, implementing the quality of experience optimizer, a tool that in fact will ensure the proper functioning of the use case within a proper policy framework. And of course, another important component, the definition of the SliceNet orchestration subplane related to the resource management, related to the service and slice orchestration capabilities, with respect of quality of experience, with respect of FCAPs, and of course with respect of the plug and play as an interaction, the plug and play through the one-stop API, the interaction with the vertical. So basically, several concepts related to the control plane principle as the 5G system requirements, service-based architecture. So the control plane is a service-based architecture built on the top of the infrastructure with several main pillars, because a 5G network as a 5G system definition is composed by radio access, by mobile edge computing, by backhaul core, and for the multi-domain scenario by one network. Different level of abstraction and let's say definition of the APIs to provide the extensibility for the services, capability to have the plug and play control of the slice. It means dynamic vertical tailor slice control exposure, introduction of the quality of experience tool, quality of experience optimization process through the QAE optimizer that provides us SLA maintenance and, of course, in different cases, the enforcement of the SLA. And the QoS management, as it can be done through a 5G system architecture to the PCF or PCRF for different forwarding function and configuration, or data plane programmability, or interdomain configuration. The other highlighted achievement, it is based on the slicing management and orchestration plane. For this end-to-end slice orchestration, for vertical service slice orchestration, or for the network orchestration, to put in place and to highlight the SliceNet information management, an information model, in fact, for the slice services, template descriptors, and different instances. Quality of experience optimization per slice, using per slice service data collection and per slice service quality optimization, and of course processing, as a tool that will ensure us the proper service level agreement for the use case in different scenarios that in fact will apply to each use cases based on each specificity, and of course the relation with the cognitive plan, with the cognitive management and machine learning techniques by proposing the different solution to solve the issues for the use cases, and that will, in fact, will interact with the quality of experience optimization. Another important achievement, also related to the standardization process, is mainly based on the business role and different relation. I mean, business role associated for each role what responsibility in terms of network service provider, digital service provider, or digital service customer. The definition of each role as a digital service customer will consume the digital services. The digital service provider will have the capability to manage and expose the digital services to the digital service customer and to deploy vertical oriented digital services. In terms of the network service provider, for the multi-domain use case definition, that will act like a manager and exposure of different 4G, 5G function, including slicing capabilities. So this administrative domains that should be managed somehow and correlated in a common framework of management architecture. So, and also identifying different scenario. I mean, the scenario when the digital service provider and the network service provider are completely standalone actors, so are playing different roles and responsibilities on using different actors, or the digital service provider and the network service provider, in fact, are the combined actors, are under the same responsibility. And this scenario has been implemented using, in fact, the smart city use case, where Orange Romania was playing, or is still playing, the role of the digital service provider and the role of the network service provider. Work Package 2 also provided a zoom on the information model that in fact is a SliceNet information model, and also it have been identified different challenges in order to define this SliceNet information model. Related to different representation in the management environment, so IETF or TMF or 3GPP have different, let's say, concepts or approaches. As TMF, it's a business concept for having different characteristics and relationships, or 3GPP is more related to properties, relation of the entity, and rules and constraints. So it has been identified the need of this information model for SliceNet. Basically supporting three main concepts for consensus of network slicing paradigms. So to bring a consensus for these activities, to define the main objects from the management modules in this part, and of course to enable these slice templates in a readable format for to apply different techniques. So based on that, the information model and concept is composed by or is using different concepts related to the use case, different types of vertical use case from URLC or EMBB or massive machine-type communication, considering different concepts from the slice service template, customer-facing services, customer-facing instances, going further to the network slice template, network slice instance, network slice subnets, and network function. In fact, all these concepts being aligned with different standardization references. And using these concepts, there have been identified different levels of information model related to the service, to the service to slice and to the resources, to the service level, levels from the service to the slice level, and from the slice to the resource level. As we can see, from the service to slice to resources, the paradigm is sustained by different physical or network function, in fact, that are composing our network function. Network function that contains is contained by the network slice subnet, of course, mapped to different network services. Different network slice subnets create the network slice that are assigned to a customer-facing service. The other concept was class service level. So from the service level perspective, as it has been presented in the information model concept, different use cases, smart cities, smart grid, whatever, e-health, remote surgery, are using customer-facing, are composing the customer-facing services that the customer-facing service template described this customer-facing service, and of course correspond to a service slice template for each of the main use cases used in this scenario. Another information model was related to the service and slice level, including or starting from the different network slice instance or network slice subnet instance that in fact are connected to a network slice instance, realizing the network slice, a network slice using a service slice template provided to the customer, to use a customer-facing service instance for the service deployment. And another important information model was a relation between the slice and the resource level, physical network function based on physical network function descriptor, or the virtual network function using virtual network function descriptor as a network service descriptor for this scenario. So this was the main information model that have been analyzed and described inside the work package 2 as a system architecture reference. So from the work package 2 summary of the innovation, we successfully achieved several points as the vertical in the loop requirements decomposition. We had different use cases decomposed based on proper specific requirement. We have defined a vertical centric multi-layer and multi-domain slicing control and management. We have defined and assumed different business role alignment, roles and responsibilities that further have been translated into an implementation in different work package for the use cases. We have defined an information model related to the service, to the slice, to the resources for the different levels. We have defined, with myself for one of the first projects, the cognitive part in the telco infrastructure for the cognitive slice management, and we have identified the quality of experience and optimization activities for the use case, and a new concept we have described, you have introduced a plug and play control capabilities for verticals in order to have the possibility to expose and to control different service requirements. For further information, I kindly ask you to visit our SliceNet website or to contact us through the emails. And of course, if we have questions, I think I have to remove the sharing.
Thank you very much, Marius. Maybe you should not have removed the sharing. Maybe you will have to refer back to slides, but that's okay. You still have the presenter role. So the floor is open for any questions. Please put your questions into the chat, then I can repeat them for everyone. Right. So you can put your questions, in fact, to everyone, not only to the moderator. Okay. So one question is here: how is the project system definition aligned with what's going on in 3GPP? So how, in fact, can you follow or align with this very, very complex ecosystem of 3GPP?
Yes, the project is in fact very complex, and we have identified from the beginning that there are different standardization bodies, there are different approaches for different activities. So we have tried to align with the proper specification for different standardization bodies, and mainly we stayed focused with 3GPP different TS for our concept related to the orchestration, to the control plane, to the composition of the function and service-based architecture. So it was an activity of identifying all these concept from other standardization bodies, or as I've said, during different project, 5GPP project, and to add them and align the project with our consideration, with the mainly focus in mind 5G system-based architecture.
Okay, thank you, Marius. There is one here in the chat. To everyone, in a multi-domain, multi-tenant environment, how are conflicts handled? Ultimately, different services are competing for common resources.
Of course, the different services for sure are competing for common resources. So, to the exposure of the capabilities of the function, we are capable to identify the network resources that are available and capable to be used by different use cases. So. The proper exposure, the monitoring, and the control of the functions can allow us to do this, let's say, decomposition of the services, for example, for the multi-domain slicing, and of course using the proper offers coming from the network service provider, using proper catalogs and inventories. The system architecture should manage this this approach for services on a different multi-domain environment.
So basically this means that different SLA levels are given to different service types, right?
Exactly.
Because there is also, of course, always the requirement for, let's say, higher reliability, which would compete, of course, for reserved resources, which are then not available to anyone else. Okay, I hope this question is answered. I have here another one. So how was the process for identifying vertical requirements and translating them into technical architecture? Can you elaborate a little bit on that?
Exactly. So for each of the use case that we have used and we have in the project, all the technical requirements from the use case perspective have been well elaborated in terms of KPIs, in terms of networking, in terms of resources, in terms of how the work it's done today and what will be expected from for the 5G system. So as I said, the vertical was in the loop, well involved in the loop, providing all these service needs, service components, including KPI, including describing the protocols, the functioning, the proper functioning of the use case, and of course of the use case scenario, that provide us the possibility to collect all this information. And all this information have been aggregated, and also it has been aligned with several interaction with different, let's say, vertical owners, in order to understand, based on these critical verticals that we have in the project, what is expected for a 5G network and for a 5G capability. So combining these KPIs, use case requirements, and capabilities with the 5G expectation from the vertical perspective, we were able to build this system architecture. Can you hear me?
Yes, thank you very much, Marius. I was muted here on my microphone. So there was one follow-up on that, and that is the vertical KPIs are usually very, very different from network KPIs, so a vertical application. And that is perhaps well, complicating, or in fact, well, complicating the translation of these KPIs into network KPIs. I don't know if you want to comment on that. I have more questions here.
Okay, let's go further.
Yeah. So there is one question. Let me see if I can interpret this correctly. What is the end-to-end slicing concept and definition from a SliceNet perspective? So what exactly? Okay. So I interpret this. What exactly do you mean as an end-to-end slice?
So an end-to-end slice represents a logical network that starts from the device or from the UE's perspective and ends at the core network level to the whatever application it will be used. It provides a logical network that corresponds to an answer to the use case communication requirements. So somehow these communication requirements are guaranteed from the network perspective through using the proper composition of the network function, of the DNFs that are composing our services, including prioritization or resource allocation from the core network perspective, from the radio access network perspective, identifying this, let's say, traffic flow for our use case at the very beginning of the entering in the network until the exiting the network. And this applies also to the multi-domain slicing concepts, having the comment that, or the argue that it should be a well-defined service profile and characteristic for this scenario.
Okay, then let me follow up on that. So the end-to-end slice is both covering different technologies, so slicing across different technology domains, as well as slicing across different administrative domains, so basically ownerships or operators, right?
Exactly.
Okay. Thank you very much. Now I have one last question here on my screen. I'm sorry if I can interpret this again. How do you define the basic management and orchestration in a multi-domain setup? I suppose this is about how do you orchestrate across multiple domains.
So when we defined the multiple domains, we expect to have, let's say, different network service provider or part of the components of the different network service provider in our service and in our scenario under the umbrella of the same digital service provider that is capable to use, to request, and to somehow expose further to the digital service customer of these services. So a common orchestrator, in fact, a service and slice orchestrator should interact with properly with a resource orchestrator and should have a proper view of each of these multi-domain network resources and capabilities, using catalogs, using inventories, using SLA and agreements in order to proper translate the digital service customer requirements from the let's say service needs and service definition, using for example different offers for these services through the digital service provider management domain that requests and is capable to deploy based on the managed domain network resources and in fact the network slices.
Okay, thank you, Marius. So I don't see other questions. Okay, there is one still. How do the verticals subscribe for slices?
So it's a system architecture from the digital service customer contact and connect through the digital service provider through the SliceNet system architecture. That means the SliceNet access subplane using plug and play capabilities and one-stop API capabilities in order to request to the system the proper service, in fact definition, the service based using the SliceNet information model. The service has a service slice template that is using proper resources for this SliceNet for this slice definition.
Okay, I hope this was answered well enough. So I would open the floor for any last questions. We're about to finish the webinar now. Okay, there seems not to be more questions, so I would like to finish this webinar with a reminder. There are more webinars upcoming. I hope you can see my screen now. So this was the fourth webinar in a series of in total 7 planned seminars so far. So there will be more seminars upcoming. The next one would be on the 21st of April, then beginning in the second half of May, on various other aspects that have directly to do with the prototyping demonstration and how this actually works directly in practice. Okay, thank you very much then all of you for joining this this webinar. Let me see if there is anything else in the chat. Okay, so thank you very much, and hopefully we'll meet you again online on one of our next webinars.